My name is Jason Michener. I am a senior manager for engineering operations at Comcast. I've been there about 8 years, working on a lot of the services that sit behind a lot of our customer service tools. So as some of you may know, Comcast is a pretty big company. We have a wide range of products and services for internet, television, and phone. We have about 32 million customers right now, and what that means is that our contractors and employees every day are doing about 1 million customer interactions. So about 12 months ago, we entered in an agreement with a third-party company to start exploring some artificial intelligence, machine learning options around servicing our customers. And it went pretty well, but some encouraging results, but we thought we could do better. So we looked around the Comcast technology footprint on what we need to make this work. And key amongst them was Comcast's award-winning natural language processing that sits behind the voice remote, which some of you may be familiar with. We also knew that we have some outstanding app dev teams, as well as some deep data lakes, just terabytes and terabytes worth of customer data and information going on about what's going on with account health as well as device health, as well as some pretty experienced customer experience folks. So Comcast decided we're going to do this by ourselves. And they came to that determination about 8 weeks before their contract with this third-party vendor was going to expire. So they gave the customer experience and engineering teams 8 weeks to build an AI ML solution for customer experience that needed to be sitting behind the My Account mobile app on iOS. So this is what we came up with. So we call it iQue. The A is silent. And what it represents for us is a combination of our customer experience teams, all our deep data learnings, all our service learnings, kind of all combined with our extreme focus on customer experience. You may have heard Comcast, we've been trumpeting it for a few years now. We've made a huge investment in improving our customer experience. So where we feel the iQue product is going to fit inside our ecosystem. So we feel that it is going to be able to deliver targeted and relevant customer solutions. So things that are not just generic, but things that are specific to you and what's going on in your account, what's going on with your devices, reasons why you may be asking for either an inquiry just because you're curious about something going on with your account, or whether it's something specific that you have a problem with your account or your devices that need solutions. So we also, the benefit there as well is with all that, we can start training AI and ML models, and as we feed and train those up, they'll be able to find things before we will as well. Right now, from a customer experience standpoint, it can sometimes be a very branch or tree model where you reactionary, as opposed to where we'd like to get with our AI ML models is to be proactive, to determine what's going on in your house, for your account, for the node, for the network, and try and get ahead of some of those issues before they get there. So from a strict engineering standpoint, and that's primarily my background, we had some pretty stringent goals for 8 weeks of things we had to deliver. From an outcome perspective, we kind of were driven by the answer must always be yes. So as we're working with our product teams, as this evolves, and there's new services or a new customer situation they want to handle, the answer can't be, if you give us $500,000 in 6 months, we can add a new feature to the application, right? We have to be able to be more dynamic and move faster than that. Another big consideration is the round trip for the customer. As we're starting out with a mobile device in the technology sector, we know that the expectation from the customer is immediate results. They don't want to sit and wait. They don't want to see bubbles floating by. If they ask a question or they're looking for information, they want it delivered to them as soon as possible. And additionally, we knew from launch we needed to have customer-driven telemetry. We didn't need, or it wasn't enough for us just to have operational telemetry about what's going on in the cloud or how our services are running. It was more about how are our customers using our application, what solutions are we delivering to them, and are these solutions effective? So in a normal delivery cycle or a historical delivery cycle, that may be something that comes after release. You put that kind of after all your engineering tasks. We had that as a mandate to have that from the beginning. So from day one, we could see what the customers were doing and how our solutions are doing. So what that meant for us, though, is not to be the giant aircraft carrier that takes 6 months of dev, and then we start adding on operations, and then start adding on some of this telemetry. We needed to reinvent our teams and our Scrum teams as small, focused PT attack modes. It's kind of how we envisioned it for ourselves. So this is what it looks like. So this is my account. My account number is not on here. Here's my phone number, so please don't try and do anything. So this is the My Account mobile app. The button here that says, hey, Jason, anything we can help you with today, is how we launch into the iQue product. So right away, we're going to our back-end systems. We're learning about you, your payment status. Is there an outage in your area? We call those things predictive. So a certain set of circumstances we evaluate immediately before you even ask a question. In this case, it recognized right away that I have a bill due in a day. So the first thing it's going to prompt me with is to make a payment right away. So I could also ask questions like, how much do I owe?
By the way, this is live?
Yes, this is live. We were live as of last Wednesday. So it tells me how much I owe. I can view bill details, and that's a deep link into other parts of the application. So what makes this exciting, at least for us, is it can respond, I think, very well to what the customer needs are. So if I don't know what I want, or I can't articulate it, I did just say something broadly like internet. We then prompt for disambiguation. We'll get some more information. What are you really after? Well, if my internet is slow, and I just say internet, go down to connection because it's a connection about my question, and it's a question I have about slow speeds, it then prompts me to do a speed test, which is what we would expect. But if I'm a little more savvy user and I know what I want, and I don't want to have to go through all this tree, I can say, my internet is slow. And it will just take me straight to the solution that's going to offer me, have the highest chance of meeting what my need is. So this is, like I said, it's currently live on the My Account iOS app. So if you're a Comcast customer, you probably have it on your phone now. It's a lot of fun to play with. But from a customer service aspect, though, instead of driving through a straight binary tree of having to go down level after level to drill down what you want, using NLP to determine what your intent is and filling it through some of our rules and some of our AI models, we're able to drive you straight to what you want. And in the end, that's really what's most valuable for us. Our customers' time as individuals is important. Their time is doubly important if they're on the line because something's wrong or they have a question that they want to ask. So how did we do this in 8 weeks? So like I said, Comcast is a huge company. We really only had 2 months to work on this. So what we did was we organized our Scrum teams by customer intent as opposed to engineering skill set. So we didn't have a services team and then a product team and then a QA team. We were all fully integrated in cross-functional DevOps teams. What that meant, though, was quite frankly, in the first sprint, it was challenging, as we needed to stitch together all the composite pieces in that first sprint. So we didn't get to spend all our time just working on services or working on Cloud Foundry. We had to work with product team and work with QA and stitch everything together. So what that meant, though, was after that first sprint, we knew when something was broken, even if it was all just mocked out. We could follow that whole tree path. So over the next 2 sprints, as we were working, we knew that something was broken, and that was kind of invaluable. Something else that we were able to do was we actually pulled everyone in together into a single room in downtown Philadelphia. So the first sprint, we worked as distributed teams, and we worked, I think, all night, Monday night and Tuesday night before the Wednesday to meet our sprint goals. one of the first things we learned was we can't keep doing this. This isn't going to work. So what we did is we rented out some space. We pulled in everyone we needed into a single room, and we knocked out the next 3 sprints to meet our goal. Sometimes uncomfortable, got a little hot, but it was really invaluable. So this is us. It wasn't.
It's back there somewhere, right?
Yeah, I'm actually sitting behind Nida, which is, we're packed in if you can't find me in a room. That's.
Also other people from
Yep.
the room here as well.
So, from a technical perspective, we were really able to do this because of all the hard work Comcast has already been working on with Cloud Foundry. So about 4 years ago, my neck of the woods, which is platforms, products, and services over in Comcast, we committed to going to Cloud Foundry. Todd Migliori, who's going to be speaking later this afternoon, can tell you a little bit more in detail about Comcast's efforts with Cloud Foundry and what we did with it. But primarily, we took monolithic Java applications sitting on bare metal and decomposed them into a series of microservices, a pattern I'm sure you're all familiar with. But what that meant by starting so early is that when we got this assignment 8 weeks ago, all the pieces were already there. We didn't have to worry about deployments. We didn't have to worry about CI/CD. All that was just taken care of. So we built on top of the discrete services layer, XSP, we built a business orchestration and composite service tier that my team, along with Chris Tatina, run called Convoy. So it's all the goodness we have for XSP and Pivotal Cloud Foundry. We then add some customer service specific and orchestration elements to that. So from there, we were able to leverage that and build this entire application based on that. So in summary for that, you can see the inherited goodness we have along the path. The things we got from Cloud Foundry, the things we got from all the hard work that XSP had been doing for years. Convoy itself, it was kind of a thought exercise about 9 months ago. And then 2 months ago, it was time to build something real. And we were able to just take all that and leverage those platforms to build something what we think is pretty cool, we're pretty proud of. So from an architecture summary perspective, this is at a high level, all the pieces involved. From the iOS, the platform itself includes natural language processing, AI ML from our Comcast friends here in Silicon Valley. Decision engine, the interesting part about this is as the AI ML models are being trained, we're getting some of them online now, we're able just to have some default rules. You saw some of the predictive intent rules as well that give us a lot of functionality as these AI ML models mature and can teach more about it. So we have platform services, common data, and real-time services. So this kind of highlights all the pieces that are built using Cloud Foundry, all the stitching between the components, the platform layer itself, the common data layer, the connections to some of the data sources. These are all Cloud Foundry services that we're able to get stood up in a short amount of time. And somewhere between 12 and 15 services is what we were able to put together. So for the iQue program, where we're headed next is right now, like I mentioned, we're on iOS. But going forward, the learnings we're getting, the customer treatments that our product teams are able to put in there, we're going to start to spread across the entire customer service domain. So the My Account web, which is a self-service website, the X1 voice remote, some of the treatments we have can be, since as we show, the platform itself, once you get in the front door, all the goodness is kind of baked in. So we can put that behind the voice remote, other apps, the customer service tool that our agents use called Einstein, and that's kind of an exciting opportunity as well. We rely a lot on our skilled agents to be able to treat some of our customers and to resolve some of their issues. But if we're able to have knowledge of other things that they've been doing, other things that they've tried, we can get them to a faster solution from an agent perspective when they're actually talking to a real human as well. The other area we're going to start to branch into is also the technician tool, Tech 360, so we can provide some help on that side as well. So we are not the first company, not the only company to be working on virtual assistants. And Vipul's here from Accenture to talk about what some of the challenges are with a virtual assistant, as well as how Accenture was able to help us at scale and at speed jumpstart this entire program.
Thanks, Jason. Thanks, man.
Yep.
So it's been really, we're glad to be part of a Comcast iQue project and looking forward to our continued collaboration. So as Jason mentioned, my name is Vipul Savjani. I'm the global lead of Platform as a Service within Accenture's emerging technology practice. So I think Jason talked a lot about the iQue, the context, the motivation of why Comcast was building it, and you even saw the demo. So I won't go into iQue specifically, but what I do want to talk about is just virtual agents and some of the challenges around building virtual agents and interesting parts about virtual agents. And we have a huge AI virtual agent practice, and we do this for many other clients. And I want to share some of the broader context of virtual agents. So the first thing is that what is a virtual agent, right? So virtual agent is a smart assistant that interacts with people or machines. The key aspects of virtual agent is that it harnesses the AI to inform, support, advise, and helping users who are using it with their tasks and challenges and the goals. So there are a couple of key components, right? Interaction is a big part of virtual agent, and then helping with actual task, performing those actions. A virtual agent has 4 key elements. So one is it's able to sense, whether that's text, whether you're speaking to it, whether you're doing it in a real time or in asynchronous way, but it's able to sense information. Once it does that, it's able to then comprehend that information, so it's able to understand what the user means by whatever that's said or given to the agent. And then it uses that information and it acts on that information. So it actually does something useful. And while doing all of these things, it actually learns so that next time you ask it to do the same thing, it does it better, faster, et cetera. So those are the key elements of a virtual agent. So that's how we define it and we view it. So the next thing is that what are the interesting things? Like, this is a tech conference and we're talking about emerging technology. So I want to go into what makes virtual agent interesting and what are some of the interesting problems that needs to be solved. So in that spectrum of sensing, comprehending, and acting, there are 2 things that are really interesting in my opinion. First is identifying what the user intends. So how do you identify what user wants to do or what user is asking for? And the second one is, once you understand that, how do you actually resolve that? How do you act on it? So these are the 2 things that I'm going to go into. So the first one is what we call basic intent identification. So there's a lot of mathematics involved, even in the basic intent. But basically, the core is a probability distribution. So it's a mathematic capability that's used. And where it starts is every virtual agent has something called intent ontology. So this is a hierarchical representation of what virtual agent is able to understand. It starts with a very general thing, and then it goes to very specific as it goes down the tree, as it goes down the hierarchy. So that's kind of the center of a virtual agent. Next thing that a virtual agent has is any system that incorporates virtual agent has some kind of a context. So in the case that we saw with iQue, a user was using an app, user has a Comcast account, user has a Comcast services. So there's a context that the virtual agent knows about. And also, that could include previous, like a session history. So if I'm interacting with the virtual agent, and I've asked about a few things before, it also includes that. So there's a lot of things that the agent already has access to. So there's a context, and just by having these two pieces of capability, the agent would be able to do a lot of predictive things. So for example, let's say that I subscribe to Comcast Xfinity service, and there's an outage in my area, which Comcast systems already know, and it's already linked to my address or my area as having an outage. As soon as I go to the virtual agent, the predictive intent would be able to say, look, you have an outage, here's what you can do about it, here's more information about it, without me having actually done anything. So this is a very powerful way of providing a proactive customer service just by having a context and having this intent ontology. And there are lots of other examples of predictive intents, like if there's a problem with the TV signals, you would be able to know. So that's one type of proactive information that an agent can provide just by knowing the context. The second is a common one, which is based on what's known as utterance. So you actually ask the agent, whether it's a speech or text or any means, and that goes through NLP. NLP will take that, again, first apply the probability distribution to figure out what user is trying to say, map it onto the intent ontology, and figure out what the user's utterance mean. And when this happens, this is not, in a traditional software development, like we would write if-then statements, or more sophisticated ones would have rules-based system. This is actually, as I mentioned, applies the mathematics to figure out what is the probability of what the user is saying, mapping onto the intent ontology. So that's the more direct way of interacting, and the example of this are pretty common as well. So things like you go to the agent and say, view my bill, and the agent would be able to narrow down to intent identification, saying that means user wants to view the billing information. Can I get a cable box with the HDMI? That means I want to manage my TV plan or TV service. So, these are the two, predictive is a proactive one, utterance-based is more direct way of telling agent what to do. And then one thing that happens in virtual agent system is that, and Jason demonstrated this in iQue, is that you have to disambiguate what user is trying to do or user is trying to ask. So what happens in that case is that a user would come and say, my internet connection, something's wrong with my internet connection. You don't know exactly what that could mean. So then the agent would ask more clarifying question and saying that, are you experiencing slow internet? And then user would respond to that question, and then agent would be able to know that, okay, what you're asking for is that you have slow internet speed, so here's what I can do for you. So there's that's the next thing that happens, is that virtual agent typically has a disambiguation process to narrow down what user really wants to do. So this is really what I went through just now, is a basic way of identifying intents, what user wants the agent to do, and this has a simple mathematics behind it. So that's one aspect of it. The second one is that once I understand the intent, whether it's viewing a bill or asking for why my internet is slow, whatever the intent that is identified, how do you resolve it, right? So there are a couple of things that needs to be considered for that. So obviously you have the context, the user context, the history, the session, et cetera. That's always there. Virtual agent has that. And based on that, the system can provide information. So now I know the intent. So going back to the bill viewing intent. So once the agent determines that the user wants to view the bill, then it can use the context to figure out what's the recent bill, when it's due, what the amount is, and then can convey to the user that their bill is due, their bill amount is a certain amount, it's due on a certain date. So that's the way a virtual agent responds. Another thing an agent can do to resolve a basic issue is it can provide a link to something else. So for example, in this case, viewing a bill, it will just give the information, but then it will give a link to other parts of system which can actually provide more information about that intent or that resolution. So that's kind of the intent resolution. And what I walk through right now is just the first maturity of a virtual agent to have a basic intent identification and intent resolution. So the next step is that how do you, up until this point, the virtual agent is very, it's a question-answer based, right? It doesn't feel like I'm talking to an assistant and somebody who I'm having a conversation with. It's just a question-answer type of scenario. So the next one is more advanced intent identification, and this is where there's the technique that's applied here. It's called Bayesian update cycle. So some of the same concepts as the basic intent identification applies here, but it goes through in a cycle, and the probability is used every time. So the example here is that I start when I open up an agent, it starts a conversation with me, greeting me and telling me how it can help me, and then I would ask a question, or I would try to engage in a conversation saying, I can't watch HBO. Then it understands that and says, I'm sorry you're experiencing difficulty, so acknowledges user's kind of state, and then say, can you tell me more about what problem that you're having, right? So it's now asking question, and in each one of this interaction, it's using underlying ontology and the probability distribution to figure out, how to get the user to be more specific about what they're asking for. So it will go down, and then ultimately it will determine that you're having a problem with watching TV or watching HBO because you have an issue with your wireless network. So it was able to start a conversation and then guide the user to provide more specific information, and ultimately it narrowed down, and then it now knows at the end of this conversation that there's a problem with user's Wi-Fi service. And similarly, there's a more advanced resolution, issue resolution, where it's not simply providing information like here's your billing amount and here's where you can go get more information about bill, but it's actually performing an action on behalf of the user to actually, so it's known as like running a script to actually execute that action. So in this case, it can actually diagnose the internet connection, potentially run a test on its own, restart a wireless router in case of a Comcast kind of domain. So this is a second type of intent identification and issue resolution. So what we see is when somebody's developing a virtual agent, they will start off with basic to just have a question answers to give information without actually using applications or other software, but just having a direct answers to the question, and then move on to more advanced identification and resolution. And while doing this, you have to learn. You have to learn about, you have to train the system. You have to learn what the user means, what the right response to that is, et cetera. So these are the three things that we see our clients going through in developing their virtual agents, is by providing basic and then moving to more advanced while learning in the process. So that's the journey. The other thing Jason mentioned is that Accenture was involved in the iQue project from very early on. In fact, it was a second sprint that we started engaging. So we helped Comcast in these 5 ways. So the first one was speed and scale. So when clients are innovating, they want to be able to do something really fast, and they want to build a solution like virtual agents, iQue at a fast pace. So what that requires is both being able to deliver something very quickly. In this case, it was 8 weeks to MVP. That required a team of about 40 to 50 joint Accenture and Comcast members. And Accenture had more than 22 people working on the team who were skilled in cloud-native technologies like PCF, Spring, as well as data, AI, ML, et cetera. So that was one thing and one very important thing. The second thing is, in this type of projects, fast-moving, it's a bit chaotic in the beginning. So we helped establish some delivery structure and discipline to do the agile process properly. So, doing all the ceremonies, et cetera. So that was a second thing that we helped out with. The third one is around, expertise in the technologies and what's involved in building this kind of systems. So, providing expertise on cloud-native systems, some of the virtual agent concepts that I talked about, as well as some of the data analytics capability as well. So that was third thing. The fourth is, you heard earlier about our Pivotal capability. So we have a strong Pivotal partnership. We leverage that here to kind of help with the advanced architecture topic. So when we're building this, there's a lot of scale involved, right? Thousands of users would be using it, asking questions concurrently. So the architecture has to be asynchronous, because there's also high availability requirement. It has to be active across multiple regions of the cloud. So we're working, we're leveraging our Pivotal partnership to help in this advanced architecture areas as well. And lastly, we have engaged with Comcast for many years previously, and we have also worked on a previous platform that Jason mentioned, was the XSP that provides all of the domain services that's used to build virtual agent. So we had that experience to quickly get up to speed and integrate that with virtual agent. So that was an important element. So it's really these 5 things that really allowed Accenture to help Comcast innovate at speed and scale. So yeah, that's all I have. Thank you so much. Jason, you want to take on?
Thanks, Vipul. So I am more of a, as you may have learned, I'm more of an app dev guy. We have some more presentations from other Comcast folks who probably a little more technical than myself. Todd's going to talk about XSP later today. We have some open source talks on tomorrow, as well as some of the foundational Cloud Foundry stuff. Neville George spoke this morning. Tim's going to talk this afternoon. And then Greg Otto is going to be on the main stage Thursday morning as well. So as you may have heard, we are hiring. So we're always looking for experienced, passionate folks. We're doing some fun stuff, working with some cool technologies, cool open source technologies. And we have a booth in the lobby that will be manned, and we'd love to talk to you if you have any questions or anything you want to talk about related to this or anything else. So thank you all for your time this afternoon. Have a great day.